So this is experiment 2 tangential to Mark's progressive R² truck concept. So this starts to get pretty cool here. Basically, I've got a lot that was in this previous version, but what I've changed is I've made it a 22-degree pivot angle instead of a 0-degree pivot angle. I'm now applying it as if it would be a real skateboard truck that you would use. I've given it some resistance, and that's pretty sweet. Let me take the resistance off. There it goes. You can see how that works. You can see how it's got that raising center. You can see how the raising center out at the front is going to be way more than it is where the cam is at. And you can see instead of the side on the front, I've got walls on the side. And the idea for this is actually, so you can see it's lined up with the cam. So these walls are actually part of the tray that holds the cam in place. And the cam is actually just sitting in there. It's not, I can pull it out with some pliers. If I can, I might be able to pull it out with some pliers. Yeah. So the cam is just printed with, it's mostly hollow. Because I'm trying to demonstrate this with my hands and get a feel for it, and I cannot exert body weight very easily with my hands. So it's a very underbuilt cam. Anyway, so the original P1 trucks had the cam encased in a cavity, and that cavity was basically performing the role of the slot by having sidewalls. So instead of having a literal slot with a circular thing in the middle, we've got sidewalls around the cam. And so I do not think this is viable for a real truck, but it's viable for a thought experiment. Anyway, the reason it worked on the P1 was because it was completely enclosed top and bottom, and so it had support all the way around, and it wasn't just a cantilever. Anyway, so I've got that. Here, instead of, so I've replaced the bushing joint with a proper, it was originally going to be a proper spherical, but then I realized it doesn't need to be a spherical, it just needs to be a roller. And here you can really see as the axle rolls over, you can see how the change in pivot angle develops as the axle raises. You can see that angle right there at the end. And I really like that visualization. So anyway, this is cool for a lot of reasons, but mostly because of how functional looking and feeling it is. This thing, like, it shows some stuff that's going on, but you couldn't really imagine using this. You could kind of imagine using this and it being pretty sweet. One of the discussions we've been having about this design, you know, not just this design or this design, but including Mark's design, is how the resistance is done. In Mark's pivot design, this is kind of rigged up to be a pivot but also provide some resistance, but really not to provide very much so that you can lean a whole lot. Here, we wanted to experiment with what we could do with resistance. And so by having the roller in the back, there's virtually no resistance in the rear. It's completely free moving. And on the front, I've got the band. And we decided to go with this because, I decided to experiment with this because in our minds, the Roja truck's resistance system is like really some of the best. It's really putting the polyurethane to work and getting the most out of it, more or less. And so we're emulating that. It's a more simplified version of it because it's basically just a band. And this is actually really similar to the O-rings that the P2s had, and even some of the later P1s, except for the fact that it's able to act in a straight line, which, anyway, it makes it more in line with what the Roja is doing. As long as you're doing this, it seems to be working really, really well. But here's the thing. So I have this one, it is about an equal distance between the pivot, the cam, and the axle. And so every millimeter of vertical raising center that happens on the cam increased up to 2 millimeters or whatever by the time it gets to the axle, right? And it's even more by the time it gets to the resistance. So this actually would provide a nice, soft, really cushy suspension-y ride. But can you see what it's doing to our resistance? And here's the thing. So this is a full truck, and this band was going to be holding up all your weight. So as you're riding it and you put your weight on it, it moves, and now suddenly not only do you not have preload on it, you've got less load than, you've got less than preload. You've kind of worked backwards. And so I think this kind of disqualifies this approach as a resistance method for this type of truck. And so I think because of that the resistance, we want to find a way to build the resistance into where the pivot is happening. So one solution would be to use a more normal bushing seat where the pivot is, right? One of the huge drawbacks of that, and why I really, really, really want to avoid that, is because of this right here, that block of aluminum that has to hold the pin in place. Because you could totally build this truck basically like a TKP, right? Instead of a pivot over here, you have a cam somewhere up here. Because if you have the cam where the pivot is, it's actually flipped around. So it's kind of backwards. But you could literally make a very similar truck to this with a TKP. And but you can see how high that pivot is compared to this. And so anyway, we're thinking about ways to solve that problem, because I really, really like how low and concise Mark's method is and this method is. The roller was never meant to be a solution. It was meant to be a solution for this phase of experiment and to remove resistance from the pivot to see what that did and felt like. Alright, so I think I just got one more thing that I want to talk about. In the previous video I didn't adequately describe this, but how high the raising center of gravity is going to be is partially determined by the width of the cam. I really, really like the amount of raising center of gravity that the other Planet P2s have, and they have a 4-inch cam, almost twice the width of the cam that I've been working with. And so one of the goals of this has been to make this all work in the footprint of a normal truck base plate. And so that's part of the reason why I've got the cam moved so far in relative to the axle. It's not just for getting more suspension and that. It's to make the cam act like a bigger cam. Okay, so basically here's the hiccup I'm finding with that. So as far as your weight coming down on the axle is concerned, the cam is acting like a fulcrum. And you're putting tons of weight down here, and you're getting tons of weight, and it's not just weight, it's going to be side to side and everything, way back here on the pivot anchor. And I feel like it's trying to get so much out of such a small cam and getting a bigger and bigger lever arm out here. I feel like we'd run into problems in what that's going to do on this end. And if we compare that to one of the things I've been thinking about is, well, what if we increase the base plate to 3 inches wide? It's a lot smaller than the 4-inch wide P2s. It's a lot bigger than what we've been working with here, but it allows us to be more gentle on this side. And the reason why it's important to be gentle on this is it's not just for like the mechanical strength of the, you know, the metal or plastic base plate, but the material. So right here, I'm just using polyurethane, and so you're going to start introducing lots of slop in the rear, and the slops, the rear is going to be able to move on you, and you'll start losing precision, and you know, you're going to lose the tight feeling of the steering. Okay, really quick, there was 2 other things I want to mention. This axle has got 20 millimeters of axle offset, which is pretty reasonable. That's pretty close to what the Roja has. And then also, I've set it up so that the center of the axle on the bottom is a reasonable distance in between the 2 bolts. If we look at these trucks here, like Mark's truck, say the axle would have been here, you can see how far into close to one side the axle is. And so that reduces your wheelbase on your decks by a lot. And it's just so far from what's typical. It's far more typical to have it somewhere close to the center. So I felt it was really important to address that, and that's also incorporated into this design. So there we go. That's the full rundown of the second experiment tangent to Mark's R² progressive steering truck. And I'm out of solutions in my head at the moment, so I don't know when the next update will be. It will probably be an update on Mark's version, not on our tangential project. But I'll come up with some ways to address some of these things that we've run into. And hopefully we're pretty close to something we can actually ride. All right. Ow. Longboard Technology, over and out.